Yes, today we'll be integrating square root of 1 plus tangent x. Anyway, this right here is for loss because you guys can see his message right here. He's doing really well right now and he says hi to you guys. And I'm really happy that we were able to join his journey when he was battling his cancer and he won, of course. Today, we will do this integral. And since we have done some similar integrals right here already, so be sure you pause the video and try this first. Okay, hopefully you guys really did pause the video and try it, okay? So if you did that, just comment down below, let me know, right? And then I would like a comment. Anyway, here we go. I'm going to take a u sub, let u equal to the square root of 1 plus tangent x. And I will isolate the x before we take the derivative, so square both sides, minus 1, and then take the inverse tangent. Therefore, we have inverse tangent of u squared minus 1. And then, right here, we'll just do the derivative. So we get dx du, but you know, I of course should just write down dx on the left-hand side. Differentiate this, we will get something over 1 plus the inside square. So we have this thing square. And of course, don't forget the chain rule. Multiply by the derivative inside, and the derivative u squared minus 1 is going to be 2u. So we have the 2u on the top, and we have the du right here. And of course, we can also simplify this a little bit. On the top is still 2u. On the bottom, we will get u squared minus 1 squared. We get u to the fourth power minus 2u squared plus 1. But we have another plus 1. So congrats, we have plus 2 then. And of course, don't forget the du. Then we take this and that to the u world, right? To take this integral to the u world. So here we go. This is going to be the integral. This right here, we know is going to be the u. And the dx has the u right here, isn't it? So we will see that. You guys cannot see. So I will put it down right here. U times u right here is the u squared. So we have altogether 2u squared on the top. So let me just put that down. 2u squared on the top over the bottom. Okay, so just kind of look at there. And we have u to the fourth power minus 2u squared plus 2, like this, okay? And du. So we are in the u world now, much better. Now, what we do next is we'll divide everybody by u squared. We have done similar things already, right? You guys know we will make things happen. First thing, we just divide everybody by u squared. I'll use the green pen. So divided by u squared, divided by u squared, divided by u squared, divided by u squared, like that. Why? Because you worked out really nicely. Check this out. You will see this is the integral. On the top is just a 2 now. Over, this is u squared minus 2 and then plus 2 over u squared du, like this. So that's what we have. And then we are going to make things happen. Focus on the denominator and we'll try to complete some squares. I will show you. So have a look here. I will write down, we have the u squared minus 2 plus 2 over u squared. Well, if we want to complete a square, don't we need something like something square? And we can have the plus or minus. Let me put on the minus first. Minus 2 times this thing times another thing right here, and then plus another thing square, right? Well, as we can see here, this is Christmas color. This is u squared, so don't we just put on u right here and that's pretty much it, right? That's pretty cool. And then we see that this is like 2 over u squared. How can I fill in the parentheses here though? Well, 2, can we look at this as 2 in the square root and then just square that? Sure, why not? So we have the square root of 2 right here. And then this is u squared, so I will just put this down as square root of 2 over u squared, yeah? And now I will just have to put this right here and this right here, so we have the u here and also the square root of 2 over 2, like this. And as you can see though, u and u will cancel, so this is minus 2 square root of 2. Earlier we didn't have the minus 2 square root of 2. It's okay, we can just add it back, so check this out. This is the new things that we're introducing, so don't forget that we'll just have to add it. So I will just put this down right here. We will have to add, this is the adding, Again, 2 square root of 2, so we can just cancel this out. And in the end, don't forget we still have this minus 2. So I will just minus the 2 right here. And the beauty of doing this is that these three things right here, it will be a perfect square, and we get u minus square root of 2 over u, and then square like that, okay? And for this, it's just a number. I will just put down plus 2 square root of 2 minus 2 like this. So that's pretty good. Then we'll see, well, why did I just put down a minus this thing first? Could I have done it as a plus? Yes, we can. So I will write it down again for you guys. We have this plus originally the 2 over u square, and we'll do the similar thing. First, we will have this square, and we have the minus 2 parentheses like this, and then we have the thing, and then this thing, square, and then something else. This time, we want the plus instead of the minus. Check this out. I will, again, enter the u in here, and look at the 2 as square root of 2 square, so I can legitimately enter the square root of 2 right here. And this is the u. I enter it right here. This and that, put it here, so we have the u square root of 2 over u. But this time, we're adding 2 square root of 2. Therefore, we better subtract 2 square root of 2, so we cancel. But don't forget, we still have the minus 2 right here, so just bring that down, okay? So that's very nice. Well, what good does this do? As you can see, for this denominator, we can look at it with two versions, right? Either this one, and I haven't completed the square for you guys yet. Or we can complete the square here, we get u plus, this is square root of 2 over u square, and this time we have both minus, so minus 2 square root of 2 and then minus 2. Well, ideally, we need to do substitution to cancel things out, and we use u sub already. This time, we can do a w sub, and this is how we can make things happen. This right here is like a new input, and again, that's the denominator, just another look. If you look at this right here, I'm going to let w equal to u minus square root of 2 over u. And if we do that, well, dw will be what? Differentiate this, we get 1. Differentiate this, we get plus, okay? Because negative something over u, the derivative of 1 over u is negative 1 over u squared. But we have the negative here, so it's become plus. And this is a constant multiple, keep it. And then we will just have the u squared like this. And then we have the du right here, okay? Similarly, we will do the same thing right here. I'm going to let, okay, we have the w, and I will just use v. V equals to this. We have the u plus square root of 2 over u. The v is equal to differentiate this guy, we get 1 minus square root of 2 over u squared, and we have the du like that. So that's the idea. Okay, so that's pretty good. Now, I don't have the thing on the top though. The top is just 2. So we will just have to see how to make things happen. Okay, I'm going to have this to be my denominator. So let me just put that down right here. And I will just open the parentheses. And as you can see, we have all that. And plus another one maybe. Right here. So technically everything is inside of the big integral as of now. Now, again, this denominator and that denominator are the same because look at here, okay? Well, we have to make sure that on the top it still ends up with a 2. For this one, we want to have this to be on our numerator. Well, let's just put that down. So I will put down 1 plus square root of 2 over u squared, okay? So we want to have this, and then just enter that. And you see this is very nice because for this one, this denominator here, this numerator here, I need to have this. And you see we have the 1 and then minus this, which is actually the opposite of that. And as you can see, 1 plus 1 is equal to 2. And this and that, they will cancel each other out. Very, very nice, okay? So what we can do next is that, well, how about let's break this down into two integrals. for the first one, we can just take a w substitution, and the substitution is right here already. So for the first integral, I will write it down. We take this integral to the w world. We will see it will be the integral. This is our w right here, okay? So we have the w square, and then this is the plus something, right? But you see, here we have w squared already, and this is actually a positive number. What we can do is, we are going to write this as plus square root of this, which is 2 square root of 2 minus 2, like this, and then square that. Why? Because we will use inverse tangent in a second, okay? And on the top, we still have this here, but the whole thing, all that is just our dw. So I'll just put this down as 1, and then the dw on the side, like so. Similarly, for the other one, we just add the integral. We take this integral to the phi world. So you know all this right here is going to be the dv. So this is pretty good. This was the dw. So on the top, I will just put on 1 over. This is our phi, and we have the square. And this is a negative number, and this is what we are going to do. I'm going to factor out the negative here. I'm just going to leave the 2 as the 2, okay? Factor out the negative, and you'll see this becomes this plus that, okay, in the parentheses. But again, I will just open the square root here. I will just do like this, and then this will be 2 square root of 2 plus 2, like that. Again, you factor out the negative here, and it becomes the plus here. And just do the square root and it's square, so you get this kind of thing, okay? So that's pretty much the idea, and then in the end here you have the dv, like so, okay? Yeah, that's pretty much the idea. And for that guy, what do we get? This right here, you use the inverse tangent formula for the integral right here, right? This is going to be 1 over a right here. So this is the a, okay, for the inverse tangent formula for the integral. So you have square root of 2, square root of 2 minus 2, okay? And then you have the inverse tangent, and the input here is the w, so you just write down w over this guy, which is square root of 2 square root of 2 minus 2, like this. So that's the first part. For the second part, you don't do inverse tangent because this is a minus. And the idea is that, in fact, this is in the wrong order. You actually have to do a minus minus. So for this particular integral, you actually have to use the hyperbolic version, but not the hyperbolic inverse tangent though. What you have to do is hyperbolic cotangent and inverse for that. This is the function minus the number, so you have to reverse it. So you actually end up with a minus here. So let me just write this down as a minus in green, okay? And then pretty much the same thing. You have the 1 over this thing, which is the square root of 2 square root of 2 plus 2. And then again, inverse hyperbolic cotangent like this. And then here we have the v over this number, which is the square root of 2 square root of 2 plus 2, like that, okay? We are not done yet because we have to go back to the x world. So now here we go. This right here is equal to 1 over square root of 2 square root of 2 minus 2. Here we have the inverse tangent, and this is the original version, okay? Okay, for this thing, let me just write it as this. 1 over square root of 2 square root of 2 minus 2. Let me just put it down first. And then multiply by w. Look back, w is u minus this over that. But what's u? U is that. So we will have the square root of 1 plus tangent x. So square root of 1 plus tangent x for the u. And then we add, oops, sorry, wrong color. And we have the square root. And the u on the bottom, unfortunately, we cannot really do anything to cancel. Let me just leave it. Again, we have the square root of 2 over the u, which is that. So the square root of 1 plus tangent x, like this. So that's pretty much the idea, okay? And close parentheses, and I think that's pretty good, yeah. Then, of course, we have the minus, as I discussed earlier, and then this is going to be 1 over square root of 2 square root of 2 plus 2, and the inverse hyperbolic cotangent, and you just write down the coefficient first, which is 1 over that, which is the square root of 2 square root of 2 plus 2, and then you multiply by phi, and phi is this, and just take that square root of 1 plus tangent x, and then you add, we have the square root of 2 on the top, over u, which is that, so the square root of 1 plus tangent x, like this. It wasn't painful at all, see? Right? So you have all that for the answer, and of course, don't forget the plus c all the way at the end. Right? So let me just box the answer right here. It's a pretty long box, but whatever. And hopefully I didn't make any mistakes. Yeah. So, just like that. And as always, please do not ask me to check the answer by differentiation, especially for this one, so please don't, okay? So anyway, this right here is it, and I will get out of the way so you guys can see the answer that I have on the board. Okay, I'm back. This is it, and hopefully you guys all like this video. And again, Lost, I'm really happy for you. And thank you for the update and all that, and happy belated birthday. And I also want to say thank you to everybody for being so supportive for my channel and also for Lost. You guys are so awesome, and I appreciate each and everybody. Thank you guys so much. Alright, so as always, hopefully you guys do math for fun as well. This right here is it. I know we have done a lot of similar integrals already, such as the integral of the square root of tangent x, such as the integral of the cube root of tangent x, and also the integral of the cube root of tangent square x, right? Today, we have one more.